Assalamu alaikum. Welcome to this MATLAB tutorial. Today I am going to teach you how to design load frequency control model of the power system using adaptive neuro fuzzy inference system in MATLAB Simulink software. Friends, the first requirement to apply the ANFIS controller as an intelligent controller is that we must have the conventional load frequency control model of the power system. For your convenience, I am considering this simple load frequency control model of the power system as shown here. On this topic, I have already made the video, namely how to design load frequency control of thermal or hydro power plant using transfer functions in MATLAB Simulink software. Therefore, if you can watch this video and apply the ANFIS controller in this model, then this model can be used for your master degree research or one of the PhD research objectives. Now just look at the model. It may be observed that in this model we are using the PID controller. Friends, some researchers have used the PID controller in the feedback loop as shown here, whereas some researchers have used the PID controller after the error as shown here. Therefore, in this video I am using the PID controller in this position for the better results. Double click on this PID controller block. You can see the parameters of the PID controller are 50, 30 and 10 for P, I and D respectively. Let's check the voltage graph using the PID controller at these values. Run the simulation. In the previous video, as mentioned few moments before, we discussed that its response was satisfactory, which was obtained after the several attempts. Now let's check the response of the PID controller when it is connected in this position. Run the simulation. You can see when PID controller is connected in this position, its response is extremely poor. It means that we need to change the parameters of the PID controller again. To do this, double click on this PID controller block and put the values of P, I and D as 1, 0.25 and 0.28 respectively and press OK. Now run the simulation to check its performance at these values. You can see this time its response is much better. Now let's learn how we can replace this PID controller with adaptive neuro fuzzy inference system based controller. As we know that ANFIS controller needs the input and output data of the system for its successful training. Therefore, to get the combined input and output data, we need multiplexer block. For this purpose, go to Simulink library and bring this multiplexer block from here to the model. Bring this block here, connect one port with the input of the PID controller and the other port with the output of the PID controller. Now go to Simulink library again, then go to Sync. You can see here 2 workspace block is available. Take this block and bring it in the model. Connect this block here, double click on this block. In the variable name write data because this is the combined input and output data. In the save format click on array and press OK. Now run the simulation in order to shift this input and output data from the Simulink model to the workspace. Come to command window. You can see in the workspace section we have data variable available. This data consists of 2 variables, namely input and output, having 911 samples each. Just double click on this data variable to see its values. You can see it shows 2 columns. First column shows the input data, whereas second column shows the output data. Now close this window. Friends, at this stage we have successfully obtained the input and output data of the model. Now we have to perform the ANFIS training. Friends, I have already made the video on adaptive neuro fuzzy inference system series to understand its basic with the title How to implement adaptive neuro fuzzy inference system in MATLAB Simulink. This ANFIS series consists of 2 parts. Therefore, it is my strong suggestion to watch those videos first for the better understanding of the ANFIS training. Now let's start the ANFIS training. To do this, come to the command window, type ANFIS edit and press enter. A new window will open showing the ANFIS controller GUI toolbox. At the first stage, we have to upload the data for the training. The training data may be uploaded from the file if already saved by you in any folder, or it may also be uploaded from the workspace section. As our data is available in the workspace, therefore select here workspace, then click on load data. Now write here data and press OK. You can see the data is successfully uploaded. Just look at the window again. The vertical axis shows the minimum and maximum range of the output variable, whereas the horizontal axis shows the total number of samples. Now come to the Generate FIS section. It has many options available. The first option asks you to upload the fuzzy file from a file if you have already saved it. The second option asks you to upload the fuzzy file from the workspace if you have the file in the workspace section. The third option is based on the grid partition. It means that this will create fuzzy logic controller by itself. The fourth option is based on the subtractive clustering. It means that this will also create the fuzzy logic controller by itself. However, subtractive clustering can only be used if we have more than one inputs in our data. As our data has only one input, therefore we cannot use this option. Due to this, we are going to use the grid partition option. Now click on Generate FIS. Now it asks about the number of membership functions as well as the type of the membership function for the input variable. You may choose any number and type of the membership functions. I am choosing 10 here in this case, and I choose triangular membership functions. The output has again 2 options. You may choose any of the option based upon your choice. I choose constant in this case and press OK. You can see new fuzzy inference system is generated as shown here. It means that ANFIS has generated the fuzzy file by itself based upon your instructions. Now come to third section, which is based on training the FIS consisting of various options. The first option asks you about the optimization method. It has 2 methods, namely backpropagation and hybrid method. The hybrid method is the combination of backpropagation and least mean squared error method. Therefore, hybrid method mostly provides the best results. I choose hybrid method in this case. The second option is based on error tolerance. Keep the error tolerance to 0. It means we want 0 error resulting in 100% accuracy. The third option is based on number of epochs, which simply means number of iterations. You may choose any number of iterations depending upon your choice. I choose here 100. Click on Train now to start the training. You can see it has started the training of the ANFIS. At the end of the 100 iterations, the minimum error is obtained as 0.012374. Friends, I think this is okay and almost equal to 0. Same is written here for your reference. At this stage, the ANFIS training is successfully completed. Now we have to save it. First, we have to export it to workspace so that we can use it in our model. Otherwise, it will give error. To export it, go to File, click on Export, then click to Workspace. A new window will open and ask for the name. Write any name of your choice. I choose LFC Neuro as the name and press OK. Furthermore, save it in any folder for your reference so that whenever you need, you can use it. To save it, again go to File, click on Export, then click on To File and save it where you want. Now close this window. Just look at the workspace window. You can see LFC neuro file is available here. Now go to Simulink library and search for the fuzzy logic controller block. Friends, it may be noted that ANFIS also uses the same fuzzy logic controller block. It is because ANFIS is basically making the fuzzy logic controller expert. That's why it is also saved in FIS format. Therefore, take this block and bring it in the model. Replace this PID controller block and connect this fuzzy logic controller block here. Double click on this fuzzy logic controller block and write the name of ANFIS file which we have designed now. Therefore, write LFC neuro here and press OK. At this stage, our model is completed. Now we can run the simulation to check the performance of the ANFIS controller. Click on this button to run the simulation. You can see the ANFIS controller has successfully provided the desired frequency graph. Friends, it may be noted that overall the response of the ANFIS is satisfactory. However, if you look deeper, it may be observed that the frequency is equal to 59.9 Hz instead of 60 Hz. It means that we have to train the ANFIS again to get the frequency to 60 Hz. One of the possible solutions to get this frequency from 59.9 Hz to 60 Hz is that we add some multiplier gain in the output of the PID controller data. By this way, the frequency can be enhanced from 59.9 Hz to 60 Hz. Let's try this option. To do this, just replace this ANFIS controller again with the previous PID controller. Now we need to connect the gain block. To get this, just go to Simulink library and take this gain block from here and bring it in the model. Connect this gain block here. Double click on this gain block and write multiplying factor as 1.018 and press OK. Friends, this factor is selected after performing the various simulations. Now run the simulation again in order to shift this input and output data from the Simulink model to workspace. Repeat the same procedure again to train the ANFIS by typing the ANFIS edit in the command window. After the successful ANFIS training, you have to export it to workspace as well as to save it in any folder where you want, so that whenever you need you can use it. Now close this window. Now bring the fuzzy logic controller block again in the model. Replace this PID controller block with fuzzy logic controller block here. Double click on this fuzzy logic controller block and write the name of ANFIS file as LFC neuro and press OK. Now run the simulation again by clicking on this button to check the performance of the ANFIS controller. You can see this time ANFIS controller has provided the smooth frequency response. Friends, in this video I have discussed how to design load frequency control model of the power system using adaptive neuro fuzzy inference system as an intelligent controller in the MATLAB Simulink software. This model can be used to complete your master degree or PhD research objectives. Furthermore, you can even write research paper from this model and you can publish it in any journal. By repeating the same strategy, the ANFIS controller can be implemented for any model related to any field in order to complete the master or PhD research. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.